OpenAI introduced its new reasoning models, O3 and O3 Mini, which are a big step forward in technology. CEO Sam Altman made this announcement on the last day of the 12-day OpenAI event. They called these models O3 to avoid a copyright issue with the TV company O2 and to keep up with their tradition of unique names. But what exactly sets these models apart? And why are they initially available only to a select group of researchers? These models are built to handle advanced reasoning tasks and set a new standard for technological complexity. A day before OpenAI's announcement, Google introduced its Gemini 2.0 Flash Thinking model, which is transparent because it shows users how it thinks. Both OpenAI and Google are creating solutions for complex problems in science, math, and technology, increasing their competition in this fast-growing area. Benchmark tests show that O3 performs exceptionally well. It's great at coding, scoring 22 points, which is 8 points higher than O1 on the verified test, and it received a Codeforces rating of 2,727. In math, O3 reached 96.7% accuracy on the AIM 2024 exam and did better than human experts in other scientific tests. It also succeeded in solving problems that no earlier models could solve. OpenAI focuses on safety and reliability by using a method called deliberative alignment in the models. This method includes safety rules written by people to make sure the models follow policies and reduce the risks of misuse and overly cautious refusals. You can now apply for early access on the OpenAI website until January 10th, 2025. To apply, candidates need to fill out an online form with details like their research interests, past experience, and links to any papers or code they have on GitHub. They also need to say whether they want to test the O3 or the O3 Mini models and explain how they plan to use them. Researchers who are selected will have the opportunity to access both the O3 and O3 Mini models, allowing them to explore their functionalities and contribute to safety assessments. However, it is important to note that access to the O3 model will not be granted for several weeks, as mentioned in OpenAI's application form. Participants are encouraged to conduct thorough evaluations, create controlled demonstrations of high-risk capabilities, and explore scenarios that cannot be tested with commonly used tools. This initiative builds upon OpenAI's established practices, which include stringent internal safety testing and partnerships with organizations such as the US and UK AI Safety Institutes, as well as its preparedness framework. Applications will be reviewed continuously, with selections starting right away. The introduction of the O3 and O3 Mini marks a major step forward in AI capabilities, particularly in fields that require advanced reasoning and problem-solving skills. These models excel in coding, mathematics, and conceptual evaluations, highlighting the rapid progress in AI research. By inviting the broader research community to participate in safety testing, OpenAI aims to encourage the responsible growth of these potent technologies. Now, let's explore the recent updates with Claude, an AI model by Anthropic. Claude is transforming the field of software development, changing the way businesses and developers handle coding. This huge industry, previously reliant solely on human effort and valued at approximately $736.96 billion, is increasingly adopting AI to enhance productivity and accessibility. In just 3 months, Claude has seen a 1,000% increase in coding interactions, which now account for more than 10% of its applications. This surge has boosted Anthropic's market value to $18 billion and drawn significant investments from major players like Google, Amazon, and Salesforce, heightening the rivalry with OpenAI, Google, and Meta. Claude is valued for its versatility, functioning not just as a code generator, but also as a virtual developer that ensures consistency across large-scale projects. Claude can handle up to 200,000 tokens, equivalent to 150,000 words or a complete codebase, ensuring consistency throughout the development process. Beyond professionals, Claude is making software creation more accessible. Its user-friendly interface allows non-technical teams like marketing and sales to develop their own tools. This shift reduces dependence on IT departments and encourages innovation across organizations. Companies such as GitLab and SourceGraph have reported productivity increases of up to 75% after incorporating Claude into their workflows. Despite its success, challenges remain. Security experts warn of vulnerabilities in AI-generated code, and there are concerns about the long-term impact on developer jobs. However, industry experts believe that these tools augment rather than replace human skills, enabling developers to focus on more complex tasks. As AI-driven tools like Claude gain traction, the landscape of software development is dramatically evolving, opening up opportunities for a wider audience to participate in technical innovation. So, what does Google's Gemini 2.0 Flash Thinking bring to the table? Let's find out. Google's Gemini 2.0 Flash Thinking model is redefining standards in problem-solving technology. Building on the success of its predecessor, this advanced model combines speed, accuracy, and transparency to address complex tasks across various domains. One of Gemini 2.0's key features is its ability to process up to 32,000 tokens of input, equivalent to 50 to 60 pages of text, and generate outputs of up to 8,000 tokens. This capacity makes it highly effective for reasoning, coding, and multimodal understanding, enhancing its utility in diverse applications. Unlike other models, Gemini 2.0 offers a transparent reasoning process. Users can follow step-by-step explanations through a drop-down menu, mitigating concerns about the opaque nature of AI. This transparency helps build trust and positions Gemini as a dependable tool for decision-making. Early tests have demonstrated Gemini 2.0's prowess. It has been ranked as the top-performing model across all categories of large language models, LLMs, by researchers at LM Arena.